Right, hi everyone. So, attempt to have enough time to change the background, etc. Just gonna get on with this because this is the second time I've made this. So, partial fractions, what are they about? Essentially, in C3, you were putting fractions together, and that way you could differentiate them easier. You could solve problems easier if you set them equal to 0. In C4, however, we want to split fractions apart in order to integrate them or to use binomial expansion. So for our integration, when we're talking about fractions, how do we approach fractions? Well, there's a list, isn't there? So integrating fractions. First thought, let's remember, Lun. Second thought, is it reverse chain rule? Okay. Is it reverse chain, i.e. can I bring that bottom up and then the power plus 1 to the power divided by a new power? Does that work? Because remember, we're trying to think of the quickest thing to do here. What's the easiest way to integrate something? So learn reverse chain. No? Can we factorize it? No? Can we long division it? No. Finally, our last resort, partial fractions. Can we apply partial fractions? So partial fractions is the last possible thing that you will try because it takes so long and is otherwise unnecessary. So if I go through my list of stuff, if I have this integral here, is this learn? No. If you differentiate the bottom, you get 2x minus 3, which has no relevance to the top, so therefore it's not that. We can't reverse chain. If you bring that up, x squared minus 3x minus 4 to the minus 1. If I plus 1 to the power divide by a new power, then I'd be dividing by 0, which I can't do. And also the derivative of the inside we've already established is not the top. Can I factorize it? Well, I can try and factorize the bottom. So that's x minus 4x plus 1. That's fine. Do they cancel? No. Long division, can't long divide it because the top isn't the same power or above than the bottom. So nothing to divide. It's already in its lowest. It's broken down to its lowest amount. So therefore, partial fractions must be our only method left. So the idea of partial fractions is to split the integral up into what's called linear factors. So I want this thing to be able to split up so then I can learn it, essentially. Learn each element, i.e. the integral will look like a learn integral. Okay? So how we split this up is we're going to put this into one constant over x minus 4 plus another constant over x plus 1. So this is what we're integrating now. And the idea is we want to find a and b and their constants, and you can clearly see that then we can learn this thing, learn each of the integrals would be learn based. So what is a and what is b? Remember what we've done is we've split this fraction into linear factors. So this is the easiest case that you can have. So for now, I'm just going to isolate the question without, complicating it with the integral signs for now. We'll deal with that after. So if these two things are always the same, that's what the three lines means, always equals 2, then that means if I was to put them back together again, because I want to equate this with this, I want to know what a and b are. How could I do that? Well, I need to make the denominators the same, don't I? So this is missing. In other words, we're putting fractions together in reverse. So a is missing an x plus 1 on top and bottom, and b is missing an x minus 4 on top and bottom. Now they've got the same denominator, which means I can put them together. X minus 4, x plus 1. Perfect. Bottoms are the same, and therefore tops are the same. So therefore 7 minus 3x is the same as a x plus 1 plus b x minus 4. And now we need to find out what A and B are by getting rid of our x values, isolating one value. So what we can do is we can say let x equal -1, i.e. what value of x will make that bracket 0. And if I whack in x is -1, I get 7 minus 3. X is -1 is the same as this first bracket goes to 0. So b -1 minus 4. So from here I can tell that b is 7 minus 3 times -1, that's 10, all divided by -5. So therefore b is -2. Done. What value of x, because now I need to find a, what value of x will make this bracket turn to 0? Well, 4. So if I whack in 4, 7 minus 3 times 4 equals a 4 plus 1. So therefore 7 minus 3 times 4, so that's 7 minus 12 is -5. So -5 is 5a. And therefore a equals -1. Cool. Right, that means that if we section this bit off then, so we know a is -1. A is -1. B is -2. Have I made any mistakes anywhere? 10 minus 5. Fine. But we'll check if we got any mistakes. So, from here, we're saying that 7 minus 3x then over x minus 4, x plus 1 is always the same as a, which is -1 over x minus 4 and -2 over x plus 1. Now I would never walk away from that without checking. So just like in binomial expansion, if you see partial fractions on your C4, you should be thinking score, because this is absolutely checkable. So if I whack 0.01 into the right hand side, which is what I want you to be doing now, okay, so you do this at the same time as me. Students who say, oh, I didn't have time to check, it's nothing to do with the checking mechanism, it's you, your speed. Your speed will get faster as you go along, okay? So if I whack that into here, the difference between the people who do well in maths are the ones who check, and C4 is so checkable, there really is no excuse to be walking away from something that's wrong. So I whacked it in there, and now I'll whack it into the original, into this one, so 0.01 into there. So use that answer button, 7 minus 3 answer, over answer take 4, answer plus 1. And I get -1.729, and I should get exactly the same. So it's different to the binomial, where you expect it to be correct to 6 dp. This should be exactly the same. It is exactly the same, so we're happy. And now you can see the advantage of this, because we need to integrate this, and we can clearly see that this is a ln situation now. So this is minus ln mod x minus 4 minus 2 mod plus 1 plus c. Quick differential to check, and you'll see that everything's all good. Case 2 then. So that was case 1. Now we're on case 2. So case 2, slightly more difficult example. Again, we could integrate this. We could use binomial expansion on this. Okay, and as this is the second time I've done this video, I hope I'm not, kind of rushing too fast. But anyway, so like before, we're trying to split this thing up into linear factors, such that we have a constant over a factor plus another constant over the second factor. But you're probably thinking that x plus 1 all squared is the second factor. No. Now that would be a logical response, but the problem is that this won't work. Now, why won't it work? Well, you see, it's impossible to put these two constants together with these denominators so that it matches this left-hand side. The adjustment just won't work, and you can kind of see how that is through long division or even putting two fractions together, it's not going to work. I'm sure you're not believing me that it won't work, and it's good to have that skepticism, but I assure you it won't. I'm almost tempted to do it to show you that it won't work, but time-wise, what we have to do is we have to split your linear factors, so this is what's called repeated linear factors, into x plus 1 and x plus 1 all squared. So if it was over x plus 3 to the 5, okay, we would need a over x plus 3 plus b over x plus 3 squared plus c over x plus 3 cubed, all the way up to x plus 3 to the 5. Do you see? It has to be split up in that way, otherwise it's impossible for you to generate that 11x squared plus 4x plus 5 on the top. It won't work. So, and you can see, alright, you can see it's not going to work because you need an 11x squared on the top. So straight away, this is going to produce an 11. This here on the bottom is going to produce an x squared, isn't it, if you multiply it out? If we times that up by the top, so x squared plus 2x plus 2 plus b, 2x plus 1, x plus 1 squared, a has to be 11, doesn't it? And that therefore will produce 11 times 2x, so that's 22x. But b is just a constant, there's no x involved, so you're not going to be able to make 14x. I hope that kind of satisfies you in just that brief example of why it's impossible that this will work. You need that adjustment, which you'll get from here. So like before, if we were to solve this, then we want to find a, b, and c. We would need the denominators to be the same so we can compare it with that left-hand side. So I'm always comparing it with the left-hand side. A is missing x plus 1, yes, but it's also missing a second x plus 1. So it's missing x plus 1 squared in order for that to be the same. B is missing a 2x plus 1, yeah, but it's also missing another x plus 1 in order to make that denominator the same as the left-hand side. Yeah? So plus 1. Additionally, C is missing a 2x plus 1. And now everything's the same. We can say top line is top line as bottom line is bottom line. So A, x plus 1 squared, B, 2x plus 1, x plus 1 plus C, 2x plus 1. Nice. And now we can go for it then, because we're trying to find A, B, and C, remember. So we need to make the bracket disappear, and that way we can find that missing letter. So in order to make this bracket disappear, x needs to be minus 1. X equals minus 1 into there will also make that disappear, and therefore I'll be left with C. So 11 minus 1 squared plus 14 minus 1 plus 5 is the A bit disappears, the B bit disappears, and now the C, two lots of minus 1 plus 1. So it turns out that C is the same as 11 minus 14 plus 5, all divided by minus 1. So C is minus 2. Done. Let's get rid of the second set then. So if I want to make one of the brackets equal 0, let x be minus a half. That will get rid of this and this. So therefore 11 times minus a half squared plus 14 times minus a half plus 5 is the same as a minus a half plus 1 all squared. So here we go, use that answer button then. So minus 0.5 equals 11 answer squared plus 14 answer plus 5. So that's 3 by 4 is the same as a half squared, so that's a by 4, and therefore a must be 3 in order for that to work. And then finally, we need to find our value of b. We found A, we found C, we need to find B. We can't, we've used all the x values that we can in order to make this thing 0. So what we need to do is, because the proportion's always going to stay the same between A, B, and C, we'll let x be the most convenient number for our calculations, because essentially it's simultaneous equations. So if x is 0, I get 11 times 0 plus 14 times 0 equals plus 5, so 5. On the right hand side, wherever I see an x, I replace that with 0. So that's a times 1 squared plus b, and 2 times 0 is gone, 1 times 1, so that's just b, and plus c, because 2 times 0 is gone. You see, we already know what a is, which is 3. We already know what c is, sorry, and so therefore we know that b is going to be 4. So, always pick the most convenient value of x. If x equals 0 has already been used before, just use x equals 1 or x equals minus 1 if that hasn't been used. You see, you use a value of x that hasn't been used before. So what we're saying is that 11x squared plus 14x plus 5 over x plus 1 squared 2x plus 1 is actually always the same as 3 over 2x plus 1 plus 4 over x plus 1, and then c, which was minus 2 over x plus 1 squared. Okay, finished, but we're not finished because we need to check. So we'll 0.01 it. So 0.01 in both sides. Make sure you're doing this at the same time. 14 plus 5, using that answer button trick, answer plus 1 squared, 2 answer plus 1 equals. So you should get 4.940980411. Whack it in the right hand side. 3 divided by 2 answer plus 1 plus 4 over answer plus 1 minus 2 divided by answer plus 1 all squared. And you get 4.940980411, and we're happy. Therefore, it's correct. And now we can integrate this thing if we wanted to. Let's quickly do that. Remember, we had to use partial fractions because we couldn't learn this thing. We couldn't reverse chain rule this thing. So if I want to integrate that, I'm now just integrating this, which is a piece of cake. Minus 2 over x plus 1 squared. Let's see if we can deal with this. We'll deal with the first two then. First one's obviously ln, so that's 3 over 2 ln mod 2x take 1. Second one's obviously ln. Third one, integrating this. This is not ln, because the chain rule, the 2 would come down, the x plus 1 would stay, always the power of 1. So we would use the next thing on our list, which is reverse chain rule. Does this reverse chain rule? Absolutely. The differential of the inside is contained next to it. So I will plus 1 to the power and divide by new power and quick differential to check. So the minus 3 would come down. That's good. But that would cancel the minus, so I need to make that positive. It would be to minus 2, and we're happy with that. Last one then. Last case is when we have what's called an improper fraction. So what we have here is an improper fraction because the top, remember if we go through our list though, this is not a problem. If we had to integrate this thing, let's go through the list. Is it learnable? Does the bottom differentiate to the top? No. Is it reverse chain? No, because bringing the power up, no, definitely not. The differential of one is not next to the other. Can we factorize? The top doesn't factorize, so we can't. Long division. Can we long divide this? Yes, we can. So if we know our order of priority, you can see this is an improper fraction because this is 3x squared take 3x take 2 over x squared take 3x plus 2. So I've just multiplied these two out. I know I'm doing this quickly. The bottom and the top have the same order of x, don't they? This is x squared on top and bottom, so of course it's long division. So if top, so numerator, has same or above order of x, it's long division, and then partial fractions will be your tactic, okay? So if we quickly long divide this, right, top and bottom, remember this slick way, so x squared, take 3x plus 2. What do we need to times x squared by to get what we want? 3. So working to the side, 3x squared, take 9x plus 6. That's cool. We didn't start with 9x, so our remainder is going to be plus 6x. And we have plus 6, we need minus 2, so we need minus 8. So now this problem reduces to 3 plus 6x take 8 all over x squared minus 3x plus 2, which is the same as x minus 1, x minus 2. You see? Now we use now we use partial fractions on this section, because we can integrate 3 obviously, but this bit we can't integrate. So my advice, asterisk it out, so 6x take 8 over x minus 1, x minus 2. Again, can we learn it? Can we factorize it? Can we reverse chain it? No. So this is now reduced to a case 1, isn't it? It's not repeated linear factor, it's just linear factor. So x minus 1 plus b over x minus 2. So very quickly again, you're making the denominator match the one on the left. So if you were to put them together, you can now say top line is top line, bottom line is bottom line. So 6x take 8 must now be a x minus 2 plus b x take 1. So you guessed it, folks, let x equal 2 to make that 0. So 6 times 2 is 12, subtract 8 is 4. So that becomes b is 4. Let x be 1, 6 times 1 minus 8 is minus 2, 1 take 2 is minus 1, so that's minus a. So a must now be 2. And we're basically finished. Our problem has reduced, if I put it over here, has now become integrate 3, and now we've got plus a, which is 2, and then b, which is 4, so plus 4 over x minus 2 dx. And we can integrate that no problem to 3x plus 2 ln x minus 1 plus 4 ln x minus 2 plus c. So again, folks, if this is going too fast, just rewind it, okay? Rewind it. Check my result. Is my result even right? Whacking 0.01. I shouldn't even integrate until I've checked it, but you know, we're already on 23 minutes on this video. Okay,